All right, so we're going to go over two different ways to do dilutions in this video. So the first way that we're going to do is for dilutions with a low dilution factor. So let's say we have a stock concentration of, let's say, antibiotic that is at 10 milligrams per mil, and we want our working concentration to be 100 micrograms per mil. So first of all, we can see that our units are different. So we want to convert one of these. So I'm going to convert my milligrams now to micrograms. So that's 10,000 micrograms per mil. All right. To figure out the dilution factor equals the concentration of what we have over the concentration of the solution we want, which in our case is 10,000 micrograms per mil over 100 micrograms per mil. In this case, it equals 100. There are no units. The units cross out, so it's a dilution factor of 100 for this case. So we consider this to be a low dilution factor dilution. Okay, so back to what we have. So we have our 10 milligrams per mil, and we want 100 micrograms per mil. So how do we figure out this concentration? We are going to use the formula that you should have learned before called C1 V1 equals C2 V2. Okay, so we can start filling in some of these values now. So our C1, we know it is 10 milligrams per mil, or 10,000 micrograms per mil. Our C2, our C2 is our 100 micrograms per mil. Okay, so we have C1 and C2. So now we need to figure out what V1 and V2 are. So I'm going to say we want to make 10 mils total. So that means our V2 is 10 milliliters, and our V1 is what we are solving for. All right, so we can plug these numbers into our equation now. So C1, V1, C2, V2. So once again, I'm making sure I'm choosing the one where my units are the same. So it's 10,000 micrograms per mil. We're solving for V1. We don't know what that is. C2 is 100 micrograms per mil, and V2 is 10 mils. All right, so we can reorganize. V1 equals 100 micrograms per mil times 10 mils over 10,000 micrograms per mil. And so now we can solve for V1. V1 is going to equal 0.1 ml, or 100 microliters. So we need to add a volume of 100 microliters of our stock, our C1, to our 10 mils. To properly do this, we don't add that 100 microliters to 10 mils of, say, water or whatever we're diluting in. We want to add 100 microliters of stock plus 9.9 mils of, let's say, water, and that's going to equal our 10 mils total. All right, so you always need to take into account how much of your stock you're adding to your diluent. All right, all right, so now let's say we have a high dilution factor. Dilution we want to do. High dilution factor. And so in this case, what we have, let's say, is an overnight, so ON stands for overnight, an overnight culture of E. coli. And what we want is a 10 to the negative 5 dilution of that. So I'm going to show you what happens if we use the C1V1 equals C2V2 formula. So if we do this, C1V1, if we start filling these in, concentration 1 is our overnight culture. We're going to call that a concentration of 1. Our C2 is 10 to the negative 5. We are diluting down to 10 to the negative 5. Our V1, we're going to say we want to pipette out 100 microliters. So it's an easily pipettable volume. And we're going to solve for V2 this time. Okay, so if we start plugging that in, and we're going to call this 0.1 ml, just to keep things safe. C2 is 10 to the negative 5. Once again, there's no units here because these are just dilutions, and we're solving for V2. So we're going to go 1 over 0.1 ml divided by 10 to the negative 5 equals V2. If we solve for that, we end up getting 10,000 milliliters or 10 liters. Okay, so although we started with a volume that is reasonable to pipette with our V1, we end up with a V2 which is such a high volume that it's not reasonable to work with in the lab. So for that reason, we cannot use for high dilution factors, okay? We have to come up with another way to do this, all right? So the way we want to do a high dilution factor is by using something called serial dilutions. All right, so to do a serial dilution, I'm going to diagram this out for you. So we're going to start here. We have a tube that has our overnight culture in it. All right, so this is not diluted. So this is basically, this was like our C1, which equaled 1 in the last example. When we do serial dilutions, we often work in volumes of about 1 milliliter. It's easy to work with in the lab. So to get to such a high dilution factor, so a 10 to the negative 5 dilution, we need to do it stepwise. There's more than one way to do it, so I'm going to show you one way that you can do this. What I have here is an Eppendorf tube. In my Eppendorf tube, I have 990 microliters of 0.5% NaCl. So we often dilute our cells into NaCl. So that's what's in this tube. From our overnight culture, we are going to take 10 microliters of our overnight culture into our 990 of NaCl. So that's 10 microliters in 1,000 microliters, which is a 1 in 100 dilution. A dilution factor of 100. or we can also write that it's at 10 to the negative 2. Okay, so there's several ways of saying the same thing. So now we went from not diluted, or a dilution of 1, down to 10 to the negative 2. So we still have a little bit of a ways to go to get to 10 to the negative 5. So we're going to do the same thing again. So I have another tube, a new tube, that has 990 microliters, 0.5% NaCl. I'm going to do the same thing now, but this time I'm going to take my 10 microliters out of this tube, out of my 10 to the negative 2 dilution. So 10 microliters out of 10 to the negative 2 into 990. We have another 1 in 100 dilution factor of 100. So if we have a dilution factor of 100, but coming from 10 to the negative 2, we are now at 10 to the negative 4. So we're almost there. So we need to do one more dilution, but we don't want to dilute by 100 this time. This time we only want to do a dilution of 10. We need to get from 10 to the negative 4 to 10 to the negative 5. So it's the same idea. We have a tube. Instead of 990 microliters, I have 900 microliters of 0.5, let's try writing that, 0.5% NaCl. So this is a 1, this is going to be a 1 in 10, dilution factor of 10. All right, so we're going to take this time to get to a 1 in 10, it's going to be 100 microliters out of our 10 to the negative 4 into 900 microliters of our NaCl, dilution factor 1 in 10. We are now at 10 to the negative 5. So this is where we want to be for our dilution. You guys will be doing this in class, so you need to be able to understand how to do this. The reason we tend to dilute like this is because if we went and plated cells right from this tube here onto one of our plates, we're going to get too many colonies to count. So we need to dilute it so that we can get individual colonies. So we will often dilute down to 10 to the negative 5 or 10 to the negative 6. To plate, what we do is we take 100 microliters out of our dilution and spread it on a plate. We then will incubate that plate overnight. All right, so recall that we plated 100 microliters of a 10 to the negative 5 dilution. And let's say we came back the next day to look at our plate, and we have colonies on our plate, which is good. So they're individual colonies. And we counted our colonies, and we have on here 75 colonies. So that's great. But that doesn't mean that that doesn't give us a lot of useful information. To get useful information, we need to take the 75 colonies and we need to convert it to cells per mil. All right? So recall that we make an assumption that one colony started from one cell on that plate. All right? So if that's the case, we now have 75 cells, but we only plated 100 microliters. We're after cells per mil. So let's convert that to 75 cells in 0.1 ml. So to figure out how many cells we have in 1 mil, we just need to move the decimal place over, move the decimal place over, so basically multiply by 10. So it's 750 cells in 1 mil. So that sounds good, but we're not quite there yet because recall we plated this 100 microliters out of the 10 to the negative 5 dilution. So we need to get back to our overnight culture. So to do that is quite simple. All we do is we multiply by the inverse of our dilution factor, all right? So to get back to our overnight culture, we go 750 cells times 10 to the 5 in 1 mil, okay? So this equals 750 times 10 to the 5 cells per mil, which is the correct answer, but it's not yet in scientific notation. So we want to convert this to scientific notation. So we have 7.5 times 10 to the 7 cells per mil that were in our original overnight culture.